Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera and greeting everyone. Welcome to our video assignment presentation. My name is Wan Kamal Firas bin Wan Yusani, holding a matrix number 2019-413224. I'm a final year student of Diploma in Science UiTM Cawangan Pahang Campus Linker, and we are from Group AS1205M. So the title of our presentation today is Gas Chromatography and High Performance Liquid Chromatography. So let's continue to our presentation. Okay, before I move to our presentation, let me show you my group member. So, first of all, me myself, Wan Kamil Firas bin Wan Yusani, and then we have Muhammad Azim bin Muhammad Azam. Next, Muhammad Amir Firdaus bin Muhammad Razwan, and lastly, we have Muhammad Arif Adli bin Muhammad Nazri. So let's start our presentation with gas chromatography. So let's start with the introduction. Gas chromatography is the separation technique of choice for smaller volatile and semi-volatile organic molecules such as hydrocarbon, alcohols, and aromatic, as well as pesticide, steroid, fatty acid, and hormones, making it a common analytical technique in many application areas and industry segments, particularly for food safety and environmental testing. GCMS may be used to separate complex mixture, quantify, analyze, identify unknown peaks, and determine trace amount of contamination when paired with the detection power of mass spectrometry. GCMS can be used to study liquid, gases, or solid samples. Analysis begins with the gas chromatography, where the sample is effectively vaporized into the gas phase and separated into its various components using a capillary column coated with a stationary liquid or solid phase. Vanillin in sample were extracted with SPMA through a few silica fiber coated with divinyl benzene or polydimethylsiloxane. So I will pass the next slide to my group member.
Now let's talk about methodology. The first step is to make a sample preparation. So how to do this? The first one is 1 gram of white chocolate is grated in the mortar to produce a fine powder and transfer it into Erlenmeyer flask, also as known as conical flask. Then the sample is diluted with solvent with low boiling point together with an internal standard. The mixture is stirred to get a homogeneous solution. Then the solution is separated by using decantation method in separated funnel, leaving the organic compound extract to be analyzed. Next, we have vaporized process. In this step, a micro syringe is used to transfer the small amount of sample into the hot injector port through the septum vial. The sample is introduced into the gas chromatography by using the spitless mode of injection. The temperature of the injection is increased in order to accelerate the vaporized process, and the sample is mixed with helium. Then the other procedure is to make a separation process. The sample is separated by using the column capillary. The oven temperature is increased in steps as the analysis proceeds. There will be the increasing of the retention time due to the same polarity in the stationary phase and the compound, causing the compound to interact stronger with stationary phase. And then lastly, the compound with lower boiling point will be elute faster, followed by the compound with high boiling point. So the analysis of the result: as the separation compound pass through the column, the mass spectrometer will detect the compound. The spectrogram will point out the retention time, and the mass spectrometer will use the peaks to determine the molarity that exists in the sample.
Assalamualaikum, my name is Muhammad Arif Adli. For the gas chromatography, I want to talk about analysis. First, qualitative analysis. The chromatogram show that vanillin is present in sample that was examined with a retention time of 9.647 minutes because the chromatogram revealed two distinct peaks. The compound of the first peak elute first, following by the compound of the second peak. Because the boiling temperature of the compound differed, this happened. The compound ethyl vanillin has a higher boiling point, which causes it to be retained in the stationary phase. As a result, the component with the lowest boiling point, vanillin, elute first. Quantitative analysis. The separated ions of vanillin are seen in this figure. The height of the peak reflects the relative abundance of the different components in the sample, and each peak represents an ion component in the sample. The molecular ion is the heaviest ion in the mass spectrum. As a result, the molecular ion peak is at 151 mZ. The compound relative molecular mass is 151, which is similar to vanillin's relative molecular mass of 152.15 gram mole. Discussion. Qualitative analysis. A sample purity may be determined. In GC analysis, the retention time may be used to determine the component in a combination. It's a great way to check for the presence or absence of a suspected component in a combination. If no peak appears in the graph at the same retention period as a standard, the detected chemical is not present in the sample. For the quantitative analysis, a comparison of an analytic peak height area with one or more standard. Due to its speed, simplicity, low cost, and broad application to separation, GC has experienced tremendous growth.
Okay, so we will continue with our presentation. So the next topic is high performance liquid chromatography, or call it HPLC. So what is HPLC? HPLC is a method of separation analysis that uses the liquid mobile phase and the liquid stationary phase. Separation occurs depending on the variation in the polarity of the analytes. Vanillin, the major chemical ingredient of vanilla, was extracted for the first time by Gobley in 1858. Vanillin is the most distinctive flavor component among the several volatile aromatic chemicals found in vanilla extract. Scalding in hot water, drying in the oven, and also drying in the sun were all used in the study curing methodology. The purpose of this experiment is to use HPLC to analyze vanillin in vanilla extract. The C18 HPLC column was used in this research. Previous research on the efficiency of several HPLC columns in the analysis of vanillin in a vanilla treatment revealed that the C18 column is more efficient than the CNN phenyl column.
Now it's time for talking about methodology. The one we are talking about with is sample preparation. The first step, the standard solution of vanillin 60 microgram per milliliter is injected into the predetermined high performance liquid chromatography system. Different concentrations of vanillin are injected to perform linearity tests. 5 ml of vanilla essential oil sample is inserted to the funnel. Respectively, each of the funnel are extracted 4 times with 25 ml of chloroform. The chloroform layer is evaporated in a water bath until it is completely evaporated. The bottom layer is taken. The solvent-free vanillin extract is dissolved with 5 ml of ethanol. The standard solution and sample are injected to the high-performance liquid chromatography system. Next, we have Dragendorf test. The samples are divided into 3 and labeled as A, B, and C. 10 ml of chloroform is used to dissolve 1 ml of sample. 4 drops of ammonium hydroxide is filtered and the filtrate is inserted to stop the reaction. 6 ml of 2 mol sulfuric acid is shaken with chloroform extract. The acid that separates with another test tube is dripped into the drop plate. Dragendorf reagent is added and then the results obtained are recorded.
For the high performance liquid chromatography, I want to talk about analysis. The result we get, first, quantitative analysis. We can determine the quantitative analysis in HPLC by injecting a 60 ml vanillin standard solution. We may deduce from the result that the greatest concentration of vanillin is 3.56%, 3.20% and 1.82% come next. Next, qualitative analysis. The Dragendorf test and the Perry test are two forms of qualitative analysis. By altering the sample after the Dragendorf is introduced, we may detect the presence of vanillin in vanilla essential oil. The vanillin standard and the sample can be compared in terms of retention time.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azim bin Muhammad Azam. Metric number is 2019-20-45-54. Now I will continue present about conclusion. The first one is conclusion of gas chromatography. In conclusion, with a retention duration of 9.647 minutes, it was able to identify the component present in white chocolate with cis vanillin. The molecule has a molecular mass of 151, which is similar to the molecular mass of vanillin. As a result, the chemical has been identified as vanillin. Next is conclusion of high performance liquid chromatography. To conclude, using high performance liquid chromatography, it was able to identify vanillin in vanilla essential oil. The maximum concentration of vanillin is 3.56%, while the lowest concentration is 1.82%. From these research, it can also identify presence of vanillin by using Dragendorf test. Vanillin has a 4-minute retention time. Thank you.